Your $1,000 smartphone is engineered to outlive its own power source, leaving you with a swelling metallic silver battery that is slowly suffocating under the weight of its own internal chemistry. My name is Frank, and today we are looking at the planned chemical suicide built directly into the batteries of our devices. We're breaking down the microscopic scarring, the growing metallic needles, and the corporate throttling designed to force you into a constant cycle of upgrading. If you are ready to look at the brutal science of battery decay, hit that subscribe button and let's get into it. The public expects a phone battery to be a clean, digital bucket that holds electrical power. We assume that plugging in a cable is like filling a tank with water, but this is a complete illusion. A lithium-ion battery is not a digital bucket. It is a highly volatile, active chemical reactor. Inside its sealed metallic pouch are three critical parts: a positive metal oxide cathode, a negative graphite anode, and a liquid electrolyte solution separating them. When you charge your phone, you are not injecting electricity. You are using electrical voltage to physically force lithium ions out of the cathode through the liquid electrolyte and cramming them into the microscopic gaps of the graphite anode. It is a brutal, physical process of molecular stuffing. This molecular stuffing is physically violent on a microscopic scale. When the lithium ions cram themselves into the graphite anode during a charge, the graphite structure physically swells and expands by up to 10% of its volume. When you use your phone, the lithium leaves and the graphite contracts. This constant expanding and contracting over hundreds of days causes microscopic physical cracking in the graphite structure. When these cracks expose fresh graphite, it reacts instantly with the liquid electrolyte, creating a crusty, solid-state scar tissue called the solid electrolyte interface, or SEI layer. This scar tissue permanently traps and locks away lithium ions, preventing them from ever moving again. Every single charge cycle physically scars the battery, permanently shrinking the digital percentage meter on your screen. But microscopic scarring is only half the battle. The true physical danger inside a lithium-ion battery comes from the growth of microscopic metallic needles called dendrites. As you charge your battery, especially during fast charging, lithium ions can pile up unevenly on the surface of the graphite anode, bonding together to form tiny, sharp, tree-like metallic crystals. Over hundreds of cycles, these sharp metallic needles grow longer, physically reaching across the liquid electrolyte toward the positive cathode. Standing in their way is only a microscopic paper-thin plastic separator wall. Once a single sharp lithium dendrite pierces through that plastic separator, it creates a direct internal short circuit. The battery's energy dumps instantly into itself, causing a rapid thermal runaway that bloats the metallic pouch with toxic gas or erupts into a violent chemical fire.
Tech giants want you to be a passive consumer of their software forever. But you don't have to just buy their products. You can build your own digital assets and own your code. And the best part? You don't even need to write traditional programming languages to do it. It's called vibe coding, and it's the ultimate cheat code.
Look at Jamal, fam. Another rejection email. He's got $1 million app idea, but he's stuck because he don't speak Python or JavaScript. He thinks learning the code takes 4 years and a computer science degree, so he just gives up. Now I'm bad. The blueprint is right there in his dusty notebook, but the coding language barrier is blocking his blessings. Sitting in the dark, looking like an NPC. But then, the homie sends a cheat code. His boy puts him onto something called vibe coding. You don't need to know a single programming language. If you can text your homie in plain English, you can build a whole app. Jamal's smooth brain thinks it's cap, but he taps the link anyway. Best decision of his life, dead ass. He's reading the course page. It teaches you how to talk to AI, so the AI writes the code for you. Communication, that's the only skill you need. You already know how to talk to humans. Now you're just talking to the machine. One click, he locked in. Time to become the architect. Now watch the motion. He's taking the course, learning the exact words to make the AI build his vision. Look at the screen. He ain't typing weird symbols. He's just typing "build me a home screen." Regular words, fam. Boom. The AI translates his English into code and builds the interface right before his eyes. An error popped up? Old Jamal would have crashed out. New Jamal just laughs because he knows how to talk the AI through the fix. He just tells the AI what went wrong in plain English, and it fixes it. That's vibe coding. That's real power. App submitted to the store. No degree required. He literally just talked his app into existence. Now look at the dashboard. Real users, real motion. He built a digital asset using the language he already speaks. Now he's got the keys, and he ain't gatekeeping. Listen to the man.
I didn't write a single line of code. I just used plain English to tell the AI what to build. It's called vibe coding.
If you can have a normal conversation with another human being, you already have the skills to build your own app today. Stop making excuses.
This course gave me the exact framework on how to communicate with the machine. Scan this or hit the link below and let's get to work. Talk to the machine. Build the app.
Stay dangerous.
Because lithium-ion chemistry is fundamentally designed to self-destruct, tech manufacturers have integrated this physical decay directly into their corporate upgrade cycle. They intentionally choose energy-dense lithium-ion pouch cells over much longer-lasting chemistries like lithium iron phosphate because they know a degraded battery guarantees you will buy a new phone within 24 months. To hide this planned decay, companies use software to artificially throttle your phone's processor. As the chemistry inside your battery decays, it can no longer deliver the high electrical currents required during heavy tasks. Rather than letting the phone abruptly shut down, the software secretly slows down your phone's CPU, making your once fast device feel sluggish and old, forcing you to blame the processor when the true culprit is a dying, scarred chemical pouch. Ultimately, every portable device we own carries a ticking chemical clock inside its shell. The batteries we rely on to power our daily lives are not permanent digital utilities. They are fragile, volatile reactors slowly choking on their own microscopic scars and metallic needles. The next time you plug your phone in overnight, remember you are not just charging a battery, you are forcing a violent chemical migration that brings your device one step closer to its inevitable retirement. If this video helped you see the technology in your hands differently, hit that like button and subscribe to Big Frank Fix. We build builders here, not background characters.